So a lot of what the kidney's role is filtering, okay? It's a huge filter for us. Two kidneys act as filters for our blood, basically. All those byproducts we make from our cells doing their normal job and leftover stuff, maybe some stuff we absorbed from food or some of the leftover chemicals from the toxins our liver kind of process, whatever it is, we've got to get rid of it somewhere. How do we get rid of it? Some of it gets end up in feces, but if it can't get rid of it in feces, then we got to get rid of it in urine. So urine and digestive tract kind of have two folds. The digestive tract was the same thing. Digestive tract was about absorbing nutrients, but we did get rid of waste. The kidneys are mostly about getting rid of waste. The term they use at the very first little body of work section on page 391 is excretion. That's a good word to call it. So process of eliminating waste from the body. So that's where the term excrement comes from. Talks about feces as well, but the urinary system's main role is filtering blood and creating waste to get rid of it in urine, and that's excretion. So getting rid of waste products is excretion. That's primarily the kidney's role. The other big thing the kidneys do for us, besides excreting waste products, the filtering of that blood, they get a lot of liquid through them in a day. So what do the kidneys do? They help us balance our fluid, okay? So fluid balance and excretion of waste. That's the two main roles of the kidneys. Because think about it, all of our blood has to pass through the kidneys and get filtered out. So there's going to be a lot of opportunity for fluid to get lost. So this is why people that have kidney trouble and stuff like that have a really hard time regulating fluids. And there's a lot of other roles that kidneys do play. That's kind of its big. It's huge for electrolyte balance as well. But that goes inside. When you hear fluid balance, electrolyte balance is going to kind of come in there, because if I'm losing fluid from my blood, I'm probably losing a lot of electrolytes that I like sodium, potassium, stuff that I need, calcium, things I need for muscle, right? Contraction, nervous system impulses, all those are my electrolytes, and I don't want to lose those, so my kidneys do a good job of regulating those. That's the kind of, I'd say, I guess there's primarily three. I'd say excretion of waste, fluid balance, and electrolyte balance, which again, another word for balance in the body is, anybody? What's the H word? Homeostasis. Homeostasis is just a fancy way of saying my body keeps everything in balance. The book does highlight two kind of secondary roles, if you want to think about it. Our kidneys do play a role in helping us regulate blood pressure. They're not the only thing, but they do play a role in blood pressure regulation. And the other thing they make the point of is very coincide is pH balance, which is acidity that we talked about a little bit, that we talk about in 10. And this is all, they line this up in like the first two sentences of this chapter, basically. But that's its goal. Acidity just means that, right, CO2 and a lot of the byproducts of our cellular metabolism cause acid, and we don't want to keep too much of that. We pretty much want to keep our acidity level high in the stomach and not really anywhere else as a human being. So to balance that out, the kidneys may have to get rid of some stuff, and they help us balance that level. So those are like its secondary issues, but the big three is fluid balance, excretion of waste, and electrolyte balance. So looking at the kidneys anatomy-wise, let's talk about the structures. You got two of them. I think most nurses should know we have two kidneys. If you don't know that, then that's kind of base level, right? We have two of them. Most all of us know we have two kidneys. So yes, you can live with one kidney. Your filtering capacity is just half of what it would be. So some people's bodies adapt if they have to do that. That's why you can donate a kidney if you were compatible with someone that you could donate to. And you would live. You would just have to kind of keep up with stuff. Certain medications you'd have to watch, certain things like that. But anatomy-wise, I'll make it this point. If you kind of, does it say on the next page? Yeah. Flip the page over to 392. It talks more about the kidney anatomy. So it also makes the point too, they are retroperitoneal, meaning they are posterior to the peritoneum. Again, that means that the backside, the posterior side of the kidneys lie against the posterior abdominal cavity. So they're not fully encased in the peritoneum. The peritoneum is not just GI tract, it's anything in the abdominal cavity, which technically includes the kidneys. But the peritoneum just covers that anterior side. The posterior side of the kidneys rests right up against the abdominal wall. So that makes them that category of retroperitoneal again. And the only other unique thing anatomically is the right kidney sits a little bit lower than the left, which is interesting because what organ you think sitting right there that takes up some of that room? Huh? The liver. The liver is really big, and it's on our right side. So the liver is the one that kind of takes up a little bit extra room. So the right kidney is a little bit shorter, or not shorter, that wouldn't be the right word. The right kidney sits slightly inferior compared to the left because the liver's in the way. And they sit up against the back wall, and that's kind of why we have love handles and some of that fat back there. I mean, I have love handles, but that's why we have fat back here, because it's a padding. Remember some of the roles of our adipose tissue, energy storage, but another thing was just cushioning and padding. So protecting organs, that's why we have fat back there, just to kind of protect the kidneys from taking a shot. But the liver takes up a lot of space, so that right kidney sits a little bit more inferior than the left. And yeah, I think that covers that part. So kidney anatomy is 392. So they have, this image is in your book on 392. They basically take a cross-section or a sagittal slice of your kidney, and they get the name, again, I really don't know. I'm assuming that kidney beans probably got the name from the kidney, but I don't really know. So which one came first, the chicken or the egg? I don't know. But kidney has like a kidney bean shape to it. And another name for kidneys is just, it's used in the book without really defining it, but one day the board will wake up. If you hear anything about kidneys, they're going to use this word, sometimes renal. Like the renal system is talking about the kidneys and everything, all the way down to your so this chapter is called the urinary system, which is, again, the goal of kidneys really is excretion. That's their main goal, get rid of waste, and that waste in this case is urine, but renal is another name for kidneys. They use that. So there's a lot of double naming for kidneys. We're going to talk about the main structure of the kidneys, which is a nephron. We're going to talk about it. But that you also probably heard of a kidney doctor. A kidney doctor is called a nephrologist, study of a nephron, because that's the main functional unit of a kidney. So there's a lot of like stuff that kind of ties into that. But renal is always renal something, or renal is always kidney something. Kidneys is our kind of layman terms. You could use renal, or you can use urinary. You could use renal system to talk about it. You could use the word kidney, talk about it. You can use urinary. A lot of double names here. Some of those you've heard before. Urinary, kidneys you've heard. Renal's another one. So let's see, where do we want to start? So let's start from kind of the outside in. So it looks pretty complicated, and it kind of is. And that's why this is one chapter by itself. Even though it's decently short page-wise, there's a lot of stuff to cover here. So our kidneys as a whole, that picture on the bottom of 392 has a lot of information, and we're going to need at least most of it. So our kidneys, like most organs, have some kind of connective tissue capsule on the outside. They just call it a fibrous capsule. Most all of our organs have some kind of thing around it. Some of them have things like we talked about, the heart. The heart's got an outside capsule. It's got a sac, that sort of stuff. Our kidneys don't do a lot of movement. So they're one of the organs that we've talked about so far that doesn't really have, it's a double-walled sac like a pleura for the lungs or the pericardium for the heart. But it does have a capsule around it kind of defining its borders. So that's always what makes organs unique. Organs are always going to have a connective tissue on the out layer, capsulating it up, keeping it all in one place. So there's these different structures of the kidneys, and it makes more sense once we look at it microscopically what's going on here. But they have different names for some of these. So we have a renal medulla and a renal cortex, basically. So I don't know, I'll do red. So renal cortex is this area on the outside they're showing you. So renal cortex would technically be the outer layer of our kidney. And that's what they're showing. And you can see it kind of dives down, but it's all this section here. The renal medulla, I'll do like a darker, I was going to do like a darker red, but is the inside layer basically. Like 2 layers of our kidneys, 2 tissue types basically, or 2 layers of tissue, renal cortex and renal medulla. So the medulla actually has a shape that look like pyramids. You see these? Or like maybe they're like seashells. This is just a different concentration of renal tissue that they're referring to as the renal medulla. Now we've heard cortex and medulla before. Anybody remember where? In the endocrine system. There's an endocrine organ that sits right on top of these guys. You remember what that's called? Yeah, the adrenal glands, the top hats of the kidneys, they're here. And if you remember, the adrenal gland secretes catecholamines, and it secretes stuff that helps us regulate blood pressure, aldosterone, and things like that. Does anyone remember this, right? Well, the adrenal gland has a cortex and a medulla. Does this ring a bell at all? Maybe? A little bit? That was a long time ago. Maybe not. So it's the same concept, basically. I was just saying that it has there's similar names. And the same thing for the adrenal gland, it's the same thing. The outside was called the cortex. The interior part was called the medulla. Same thing here. But those adrenal glands are sitting on top of the kidneys, and we'll mention them again because the adrenal glands kind of operate their own function. They're under direction of the whole endocrine system, but they have a lot to do with the kidneys themselves. So I got my renal cortex and renal medulla. Go back to that. What color was I using? Like a dark red? I don't even remember now. So this medulla as well, they have kind of a double naming for the areas that are medulla. They call them renal pyramids because you look at this image, right, and the areas that is medulla tissue, what do they look like? They look like pyramids, right? So they kind of get this name as renal pyramids because of the way they look. It's not anything specific. The only reason they use that name is to talk about kind of how urine is formed and the flow of urine as it's formed. So we're going to talk about how we make urine, but at this stage, it happens mainly in the renal medulla, the renal pyramids. Again, renal medulla and pyramids is the same thing. They're talking about the same thing. They're just saying that, hey, the medulla is shaped like pyramids, and it makes sense, actually, why they're shaped like this, because it's all about kind of taking waste products, taking liquid, and forming it into urine. Well, it's all got a funnel. The whole kidney, if you look at it, it's like a little funnel system. Has anyone seen a funnel, right? Like a funnel you would put in something, or a funnel you put engine in your car. You know what I'm talking about, a funnel, right? People? Funnel? Okay. Making sure we know what a funnel is, right? So the renal pyramids act kind of like a funnel, basically, where everything kind of gets deposited towards the end of the top part here, the point of the pyramid. And so if I'm imagining urine, for now, we'll just say that urine is made through the combination of tissue that is your medulla and your pyramid, aka, and the cortex. They all make urine. So I'll do yellow, they'll kind of navigate as urine. And so urine is kind of deposited from the end of these renal pyramids. These are my drops of urine. And like a funnel, they're all going to kind of end up in these guys, which they call calyxes, a major and minor calyx, which I think is a little bit too distinct. We don't need to make that distinction. But this area that this urine is ending up in, they're calling these calyxes. They call them a major and minor just because basically they're saying that each renal pyramid is going to have its own little minor calyx, and then they all meet together to form a major calyx, but I think that's like too much in the weeds. Basically, these tubes off of these pyramids, these are your calyxes, where urine is being deposited, okay? So I'm just kind of combining these two and just saying, hey, where's the urine form? Well, it forms through the tissue of the medulla and the renal pyramids in that area, and then it's going to be deposited into a big tube called a calyx, okay? That's all I'm saying. So once I'm in here, we're in like a tube now. We're not really in any kind of tissue type. We are in an open tube that's just for receiving urine, the waste product, the excretion. And when urine hits here, it all meets together in all the different calyxes off all the renal pyramids. And it ends up in this area here, this large area, which of course they have a name for this because why wouldn't they? That's too big. This area here. So there you can see that all the urine is going to meet up here. They call this the renal pelvis. Why? I don't know, man. I don't know why we're using pelvis, but that's what they call it. So again, this is repeated on both kidneys. Both kidneys look exactly the same, do exactly the same job. Just for redundancy, I suppose, and for efficiency, we have two. And so I've made urine. We're going to talk about how we get there chemically, but I've made urine. It's going to travel through these renal medulla pyramid shapes called renal pyramids. It's all deposited into the calyxes. The calyxes all meet together in this structure called the renal pelvis, where all the calyxes meet. That's your renal pelvis, and it's just a little resting reservoir. Urine is dumping in there. So urine is in here, and then it has to go get out of the body, right? That's where it goes next. So urine's in here. Where does it go? It goes down here, which a structure you guys have heard before maybe, called a ureter, or ureter, I guess, if you want to call that. I call it a ureter. What color are we going to do? We're going to do purple. So this structure here off of the renal pelvis is a ureter, and this is on the way to your bladder. And this is, again, repeated on both kidneys. Both kidneys have a ureter coming off of them. And so now we are on our way down to the bladder. So officially, once urine has hit that ureter, we're out of the kidney now. We're still part of the renal system and the urinary system, but we're not physically in a kidney anymore. We're on our way down to a bladder. So urine is traveling this way. Down to your, that's a really crappy bladder, but that's a bladder. So if I'm talking about the flow of urine, basically it's kind of starting in the renal medulla tissue called the renal pelvises. It dumps into calyxes. They all meet together in the renal pelvis. And then that flows into the ureter on down to the bladder. And we'll talk about the bladder and the other structures, but we tracking with me there. I know that seems way more complicated than it needs to be, yes.
So is the medulla, is that where the formation of urine is beginning?
Basically, yeah. Like you wouldn't call it urine, you would still call it. So we're going to talk about the nephron, but basically in the medulla, it's an opportunity for us to still retake some liquid and some stuff we want to. So a lot of what the kidneys do, is they push out a lot of stuff, sometimes good stuff, a lot of fluid, a lot of nutrients, a lot of electrolytes, and then they reabsorb it before it turns into urine. So that's how they filter stuff out. A lot of it's filtered out by pressure, and they just push a lot out. And so in the medulla tissue, we still want the opportunity to kind of take some of that back before we send it on out as urine. Because kind of once it's out of the tissue, that's the medulla, once it's out of those pyramids, and it's in the calyxes, there's no getting it back. There's no cells that reabsorb anything. It's done. Once any liquid has met the calyxes, we're just in a tube now. And we're just flowing with the rest of the flow out and out of the body. So as far as the chemical process of filtering and then maybe reabsorbing stuff that we want to keep, that's all happening in the tissue that mainly is the medulla. Some of it does happen technically in your cortex, but a lot of it's most of it's really happening kind of in the cortex, and then the final process in the medulla, and then urine. Okay. So yes, you could say the medulla, the renal pyramids, is the formation of urine, because Once it's out of there, you wouldn't necessarily call it urine, but there's no real absorbing it again. So once it's in a calyx, it's going to end up coming out your body as urine. There's no other option to reabsorb it. So make sure. Yeah. So again, I'm doing the color coordination just to hopefully kind of help show what's happening here. Again, yellow for urine is flowing here. So cortex, the medulla of the tissue. Once I've left the pyramids, that is the renal medulla. I am in calyxes. I am now urine because there's no going back. Calyxes all meet up in the pelvis. Pelvis flows into the ureter on down to the bladder. So we'll talk about the bladder and stuff later, but we need to talk about what's going on chemically and like on the microscopic level in this cortex and medulla. Like what's happening in here to turn my blood into urine? That's the big point of this whole chapter. What's going on inside here to turn that? So let's see what we say here. We've got, I don't know why any of these aren't showing up, but that's neither here nor there. The medulla of the kidney is, so we have some options. What do we think? This one is messing with you guys probably on purpose. I don't know why these aren't showing up. These are all just boxes. I don't know what's happening. My computer's having a fit. You can see the mouse is glitching. Most people went inner part of the kidney. Yeah. If you're going for the most accurate answer, you just go cortex outer, medulla inner. Don't get hung up on anything else. Again, renal pyramids, confusing. Renal pyramids is just the name for the shape that the medulla makes. That's all it really is, okay? So hear me there. The renal pyramids thing is just the name they give the shape of the medulla. And a lot of the medulla is where urine kind of forms, where it transitions, okay, from just liquid and waste to whatever. So which statement is not true about the kidneys? Not true. Heard 3 so far. I don't know why this thing's glitching. This computer, this poor thing. Most people have gone with 3. Don't pick that one. I mean, there is a condition where you're born without one kidney, but when we talk about anatomy, obviously we're always talking about statistically the most consistent anatomy of people, which is that we all have 2 kidneys. Yeah, so the correct answer is number 3. Kidneys do not lie directly across from each other. That's just saying, if I said directly across, that means they're even Steven, just right aligned. They're not. The right kidney's slightly lower because there's a big liver in the way, and it's kind of, that's how our body is designed, to kind of make room for that. There's a discussion on page 393 is where we start kind of like the real in-depth discussion for the next little bit about a structure called the nephron. So you don't need to know too much about arterial flow, but the nephron. Dun, dun, dun. So if you, there's also one of these diagrams here. It's hard for everybody to see, but you can kind of see it shows blood flow and kind of what the kidney looks from that sagittal cross-section. And then basically it's zooming in on what we're about to talk about called a nephron, which just looks like a bunch of lines on here, but that's a zoomed in view of it. So how I always look at the nephron, that's why the doctor that studies the kidney and is a kidney doctor is called a nephrologist, because most of what the kidney is, because you saw it, once we hit the calyx and the renal pelvis, we're just in tubes. There's not really a lot of chemical stuff happening after that. The rest of the urinary system that we'll talk about is all just dedicated, really, tube system to getting urine out of the body. Once we hit the renal pelvis and then the ureter, we're just worried about getting urine out of the body. There's nothing else chemically happening. happening. So where's the real meat and potatoes happen? It's here in that cortex and medulla area, especially the cortex, and that is the nephron. So it says filtration unit of kidneys. If you kind of remember, I told you osteon was the functional unit of compact bone. I look at this like the functional filtration unit. This is the main thing. This is like the kidney cells. The kidney just has connective tissue, and it's got these bad boys, nephrons. That's all the kidney's really got going for it. It has, obviously, connective tissue and cells that keep it alive and keep its structure, but as far as specific things the kidney does, this is it. It's just got these guys, nephrons, this structure. So they're called nephrons. They're filtration unit of the kidneys. This is where the kidneys make their money. This is where they do what they're supposed to do. So they primarily lie in the cortex. So if you kind of see this dividing line they're showing us here, primarily nephrons lie outside in that cortex, but they do dip down into the medulla. I don't know what I'm writing. So primarily they're lying in the cortex. So if I asked you primarily where a nephron lies is in the cortex, bless you. But that's kind of a weird question anyway, because they do reside in both. Now, we're all different anatomically, and that's why this picture is like all conjumbled. But what they're showing you in this picture basically is some of these nephrons up here in the cortex, and they dip down with this loop that we're going to talk about into the medulla before they eventually head towards the medulla, and they head towards the end of that little pyramid shape to dump their urine into the calyx. So, structure-wise, what's happening here? This is the filtration unit because this is where blood. So our kidneys, every nephron, we have millions upon millions of nephrons in the kidney, and they all have their little own arterial flow. They have their own artery that comes in there because we want to filter blood. So the book at the very beginning said that we filter some off like 5.7 liters of fluid from blood a day or something like that. But we are having our blood flow go through here. I mean, 20-30% of our blood flow in a minute is getting through the kidneys. So that's all about blood flow because the goal is filter out waste products. Our cells are always working. Our body's always doing stuff. Cajillion times a minute. That's not a real word, but a bunch of times a minute. And so we always are filtering. So blood comes in. And in arterial, if you remember, arterials are the smallest artery. So blood comes in arterial. So I'm just going to give you kind of the whole spiel, and then we'll break it down, okay? So I'll give you the whole thing, and then we'll break it down part by part. Now, they have an afferent and efferent arterial. Don't stress about that so much. That has to do with an afferent coming in, efferent going out. If you did ever remember that, if you go back far back to the nervous system, remember we had afferent and efferent neurons. You kind of remember that? Yes. So afferent was associated with sensory, which means going back to the brain, and efferent was talking about leaving the brain. And so that's where they're getting these names too. Afferent's coming in to this nephron structure, and then they have an efferent arterial that comes out. But, so what's happening here is they come in, blood flow comes in to this structure here, this little conglomeration. So this is kind of wacky, but you're like, what is this? So if you look at that, it's called a glomulus. Glomulus. Or I always just say glomerulus. So glomulus. You could say glomer and then ulus and be done, right? Glomulus. So this is kind of a wacky thing, but what it is this mess of that artery. That artery comes into this little capsule. What's on the outside is called the Bowman's capsule, but we'll get there. It comes into this whole structure they kind of refer to as the glomulus for the most part, but, well, they don't refer to it here, so let me just backtrack some. This conjumbulation, this like snake lattice work of this arterial is the glomulus. It's encased in a capsule. So basically what happens, it comes in the glomulus and it branches off and does all these branches. It looks like spaghetti in there. Well, what do you think that does to an artery? Arteries are high pressure, right? They're closer to the, they're thicker wall a little bit, and they're high pressure. So this works just kind of like our capillaries does. Our capillaries do their exchange based on pressure, right? That was whole filtration thing. Same concept. The whole key term here is filtration. That's what's happening. When that artery goes into this structure, the glomerulus, and folds up on itself, pressure rises and it pushes stuff out. It pushes fluid out. It pushes waste products out. It pushes some good stuff out too. And when it does that, it's going to start going in this tube system that is the nephron. The nephron is like a tube system. So a lot of our kidneys is just a tube system within the tube system, really. This tube system is all about basically reabsorbing that stuff and letting go of waste. So our glomerulus is kind of indiscriminate, meaning it's just high pressure. It has no thought process. Stuff just gets pushed out in the glomerulus. And our job, the rest of the nephron, is to get that stuff back. So along this path of waste products and good stuff, you can see that the artery comes back out and actually messes around and ties itself around these tubes of the nephron. And that's because we want to be able to push stuff back into the artery. We want the ability to reabsorb stuff. So a lot of what the kidneys do is that first filtration, boom, high pressure, I'm pushing stuff out. But then really what they're doing is a lot of reabsorbing so that we don't waste anything. So a lot of the filtration is just a mass, no holds bar event where they're just pushing stuff out. It could be good stuff. It could be waste products. It could be fluid we want. Then the rest of the job of the tubes of the nephron is to reabsorb that stuff. That's the rest of their goal. And so I always look at the nephron breaking it up into two sections basically that have structures in them so that you can kind of get them. And again, you can see that there's a capillary bed that kind of is embedded in part of this nephron, and they all have that. Again, for the same concept, reabsorb. Filtration is a non-discriminate, just poof, push stuff out. The rest of the nephron's job is to kind of help us decide what to reabsorb, what to let go of. And so that depends on our electrolyte balances. That depends on how much fluid we have. If I'm overly hydrated, which doesn't always happen, then maybe I'll let go of some more fluid. But if I'm dehydrated and I'm in the desert and I got no water, my nephron tubes are not going to let a lot of fluid out, right? They're going to hold on to a lot of fluid. Does that make sense, what I'm saying there? Maybe. Okay. So if you turn your page to page 394, it starts breaking this down a little bit more in depth. So like I said, I like to look at the nephron just in two structures to keep it a little bit simple because it looks complicated when you look at it as a whole like this. And again, this is what every nephron looks like to a degree. They're all kind of randomized with their tubes, but they all have the same structure. And so the first structure, again, two structures to the nephron. The first one is called the renal. I always think of it like corpuscle. It's not how you say it, but for some reason I think of, this is just me. I have a weird brain. But has anyone ever seen The Shining? Mm-hmm. So if you know the main character, one of the main characters, he dies in the snow, like frozen, and it's just a shot of him like this. He's a corpuscle. Get it? Okay. I don't know. My brain goes corpuscle for some reason, but it's corpuscle. I don't know. But the renal corpuscle, let me say it right, is just this structure here, okay? This first part right here. That's all this is. Again, I'm breaking the nephron into two structures. So within this renal corpuscle, we have this membrane that surrounds the glomerulus. This is called the Bowman's capsule. It encapsulates the glomerulus. So this guy here. That's the Bowman's capsule in green. And you see if I take it, right, it looks like this. It's just a capsule. That's what it's looking like. Surrounding this spaghetti-like work of an artery, and that is called the glomerulus. So this artery coming in, they have different names, right, coming in, going out. But when I get in here and it branches off and it forms this spaghetti, that is the glomerulus. So that's all there is in the renal corpuscle. Okay, the renal corpuscle just this Bowman's capsule surrounding the glomeralis, and what it's doing again, if I break it down, what the nephron's doing about filtering out, that bam comes in the glomeralis, branches off and forms this spaghetti, whatever this is, and causes a bunch of pressure and pushes stuff out. So it's going to push stuff into the Bowman's capsule, and the Bowman's capsule job is just to grab that stuff, whatever it pushes out. And then this liquid full of electrolytes or whatever else starts traveling down a tube system that we'll talk about next. But that's all that's involved. So there's only two structures in this renal corpuscle. Bowman's capsule encasing a spaghetti latticework of artery called the glomeralis. That's it, okay? And this is where the filtration, bam, starts. Filtration starts here. They're trying to, again, filter out whatever. It's going to be a big push for stuff to come in. And the reason I spend so much time on the nephron is because the nephron is important. Because a lot of medications, especially medications we talked about before, diuretics. Remember talking about diuretics? What do diuretics do? Make you pee, right? They're trying to increase fluid in your urine to get rid of fluid. Most diuretics do something to our nephrons. That's their mechanism of action, meaning that's how those medications work. They do stuff to our nephrons. So having a basic understanding of the nephron structure is going to be helpful in you understanding how those medicines work. So we've got Bowman's capsule surrounding, encasing the glomeralis. That's my renal corpuscle. The second part of the nephron, again, breaking it up in the tube they talk about down there on the bottom of page 394, is I'm just going to call it the renal tubules. Let's keep it short and sweet. The renal totally tubulars, dude, okay? That was, that's an old meme now, but anyway. Totally tubular, like the surfers. All right. So the tubes, the renal tubes is the second part, and you can see that stuff that got filtered out heads towards the tube system. I think the book makes the point later, before I say something about the renal tubules, I will say that this liquid is not blood anymore, right? It's not plasma either, because this is small, so it's just like a capillary where there's a lot of stuff we don't really push out and filtrate. We're probably not going to push out too much glucose. We'll push out some. We're not going to push out too many proteins because they're big. Some will get through. But overall, there's stuff that we never usually want to let go of, and you guys know this already, but proteins and glucose kind of fall in that category of just molecules that our body needs for energy or needs a lot of, and so we are just not going to get rid of them that often. So sometimes they get pushed out in this, but the point I'm making here is that this liquid is not blood plasma anymore. It's not just water, so we got to call it something. That's how our book works. That's how science works. We got to call it something. So this liquid that has left the Bowman's capsule and heads towards the tubes, they call filtrate. They call this liquid filtrate because all it is just filtered liquid. It has been filtered out, pushed out through the glomeralis into the Bowman's capsule. This is filtrate now. So when they talk about things like filtration rate and stuff like that with the kidneys, they're talking about this liquid, whatever has been pushed out. Just like you remember lymphatic a bit, right? The stuff that's in our lymphatic vessels is called lymph, but it's nothing special. It's just fluid that is left over from tissue, capillary exchange. Same kind of concept. We can't call it blood plasma. We can't really call it water, so they call this liquid that contains whatever filtrate. So the renal tubules. So the rest of this is the renal tubules. So again, you can see that the renal corpuscle is just this first part. That's all they're saying is the Bowman's capsule encasing the glomeralis, okay? It's cool, I think. I had to think about it for a second. And I don't know why it's called Bowman's capsule. I assume the guy that discovered it is named Bowman. I don't know. That was what I assume with most stuff. Okay. So there's your renal corpuscle. The rest of this is the renal tubules, okay? So pretty much after that, everything back this way is going to fall under renal tubules, okay? So they have a flow and they have names. Of course they have names. This matters especially again when I talk about those diuretics. So you have the first tube you get to after you become filtrate and you're pushed out into the Bowman's capsule is called the proximal convoluted tubule. How what a name that is, huh? I always love the convoluted tubules because the nephron is convoluted, which means it's complicated or confusing, if you know that convoluted word. So proximal convoluted tubule. Sometimes they shorthand it like this, PCT, sometimes, not always. But remember proximal and distal? I told you can never forget stuff, right? Proximal means closest to the point of attachment or origin, in this case. Distal means furthest from the point of origin. So the origin, the origination point of the tubes is the renal corpuscle. So this first section is called proximal convoluted tubule. Now again, we're not going to go too in-depth on that. The reason they have different names for these though is because different areas are either reabsorbing certain stuff, but again, the renal corpuscle is all about making filtrate. That's the initial thing. The renal tubules are all about reabsorbing stuff that we don't want to let go. And how do we decide that? A lot of it has to do with hormones, fluid balance. Our nephron is really good at reading the tissue around it and understanding what we need to reabsorb and what we're okay with letting go in urine, okay? So this middle section, what color can we do? We can do purple. They call the loop of Henle. Sometimes they call it the nephron loop. I always just stick with loop of Henle most of the time. But again, that's what they're showing here. They're showing us on this crazy wacky diagram. They're showing you these loops that come down. These big loops coming down. Those are loops of Henle on nephrons. Some different nephrons. Those little red guys are the glomularis in the Bowman's capsule. So they're kind of showing you in that regard. So keep in mind that right about here is a little dividing line. This is renal medulla tissue, and this is renal cortex tissue. So most of what's happening with the nephron, you can see, is in the cortex, but that loop of Henle, or that nephron loop, dips down into medulla. So we have proximal convoluted tubule, we have loop of Henle, we come back up, we have another tube that's called distal convoluted tubule. Distal convoluted tubule. I'm running out of colors. Okay. So distal convoluted tubule, sometimes DCT. So we have proximal convoluted tubule, loop of Henle, distal convoluted tubule. Proximal and distal, if you can't, that's why I said you can never forget stuff. That is actually, the book gets a little confusing with this, but if you're looking at page 394, it talks about, it has like them labeled 1, 2, 3, 4. It talks about this last structure that's called the collecting duct. It kind of makes you assume that it's part of the nephron. And it kind of is, but it kind of isn't, okay? Why do you think I'm making that point? Look at this collecting duct. So the last structure I'm going to talk about is a collecting duct, but in my mind, okay, I'm going to take this green line. This green line was representing that renal tubules. So if I go back, my renal tubules to me end right about here. That's your nephron structure. The collecting duct is outside that. Why? Because the collecting duct can collect from multiple nephrons. There's not one collecting duct for like every nephron. I'll do yellow for it. That's what all these branches are. So these branches they're showing you, it looks like kind of a tree with its branches cut off. These are connecting to other distal convoluted tubules of another nephron. So the collecting duct can collect from multiple nephrons. That's what they're showing you. And if you read it there, it's talking about it receives drainage from distal convoluted tubules of several different nephrons. So to me, it seems a little bit confusing to include a collecting duct as one of the core structures of a nephron if I can have collecting duct for all of them. So you have to know, collecting duct is part of the nephron, but not part of it individually. If I'm talking about an individual nephron, it's going to be connected to a collecting duct, but collecting duct collects from multiple nephrons. So there's not one collecting duct for one nephron. It's just a giant one that's going to get multiple. Because again, you got to think there's millions upon millions just in a small area. So the collecting duct is kind of where this takes place. So far, this was all about filtrate in the renal corpuscle. The renal tubules are all about reabsorption. Again, reabsorption. I don't know. Whatever. I don't even care. Whatever. I have a master's degree. I don't have to spell. That's what I'll say. I'll say the same thing if I ever get my doctorate. I have a doctorate. I don't have to spell. The renal corpuscle is all about just making that filtrate. So again, these are the two main structures of the nephron. The goal of the renal corpuscle, make that filtrate. The goal of the renal tubules, reabsorb the good stuff from that filtrate. Get rid of the bad. Once we get to the collecting duct of multiple nephrons, we're all about turning this, whatever liquid it is, turning filtrate into urine at this point. So this is where it kind of racks. So filtrate into urine is the collecting duct. That's the goal of our collecting ducts. So by the time, and you can see the collecting duct is going down, right? All this stuff is going down. The collecting duct is going to the medulla, and you have to imagine that all of the collecting ducts of each of those renal pyramids, right? These little sections here that look like pyramids, well, is going to have millions of collecting ducts that eventually reach the peak, the little point of the pyramid, and they dump into the calyxes. So again, theoretically, once we've left the collecting duct, we are officially urine. There is still some reabsorption happening in the collecting duct. Mainly, it's reabsorption of water. So it's only focused on reabsorbing water. That's the main thing for the collecting duct. Yes. Renal tubules? I mean, mainly reabsorption. There's not really anything else. I mean, turning that filtrate into urine eventually is what they're doing, but that's what reabsorption does. Again, imagine filtrate is like just a random pressure change that causes a bunch of stuff to get pushed out, and the rest of the tubule's job is to just collect stuff. If we didn't have the tubules, right, just imagine that our nephrons were just consistent of the renal corpuscle. They were just a Bowman's capsule and just that glomeralis, and all we had was that went straight down to the calyxes and was out in urine. Our urine would be just as watery as the water we drink, and we would be dead because we would not be waste products. We'd be so mixed up with good stuff. But our body can't necessarily filter without getting rid of the good stuff and then having to reabsorb it. So the main job of renal tubules is reabsorption. That's their main role. There's not really much else they're looking for.